What is up, guys? Welcome to the second episode of Math Made Easy. And I was thinking a little bit about, kind of doing the second part of the first episode, getting into some graphing of linear algebraic equations. But I thought that for some of you folks who are struggling at geometry out there, I should do a little bit of geometry. So, I am Kirk, and welcome to another episode of Math Made Easy. And this is about trapezoids. Right? Trapezoid, great thing. What makes a trapezoid a trapezoid, It's really not that special, guys. There are one pair of parallel lines. So, in this case, I will tell you that AB is parallel to CD. That is what's given. So, a trapezoid is isosceles if this angle and this angle are the same, or if these two angles are the same. If it has like two sets of parallel lines, it can't be a trapezoid. It's only one set of parallel lines, right? Because if it was two sets, that would make it a parallelogram, and we don't like those. Well, I mean, we do. So, basic trapezoid knowledge, okay? We're mostly going to be working on areas of trapezoids. We can get into perimeters of trapezoids a little bit, if you guys really want, but I don't think that that's too big of a difficulty. But, I'll do what you guys want, because this is ultimately a channel to help you guys with your maths. So, I drew a mid-segment here, right? So that means the distance from here to here and the distance from here to here is the same, right? It doesn't really look like it, but that's fine. So this is parallel, right? And this also means this length is the mean of AB and CD. So it's going to be the length of the midsegment, the mean of the two bases. So AB plus CD divided by 2. And we are going to multiply that. We're going to multiply that by the height. So let's make a little point here that I will like to call E. BE right here is an altitude, right? I know it's an altitude because there's a right angle there. Okay? So, it's going to be BE times the midsegment, the mean of AB and CD, to get the area, okay? One more quick observation that I want you guys to know is a trapezoid, no matter how it looks, it's always going to be it's going to be kind of comprised of, going to be kind of made out of two triangles and a rectangle. Okay. So here we have some information, right? I want to find the area of this trapezoid. All we know is that BC equals 2 times the root of 2, so root 8 if you prefer to say it that way, but I'll always give you roots in simplest form, kids. Then we have DC as 10, and then we know AD is equal to BC, which is of course 45 degrees. We gotta find the area of this thing. First off, I don't know AB. Second off, I don't know this altitude. What am I supposed to do? So, let's think. So I have this altitude, let's call it BE. And we know this is an isosceles right triangle, right? Because, the altitude is always perpendicular to the base. So that's a 45 degree. That means this is also a 45 degree. And this is a 90 degree. So we know that this squared is going to equal CE plus BE squared. So, CE squared plus BE squared, sorry guys. And that will, those are equal, so we can just say this squared is 8, half of that is 4, root 4 is 2, so we know this is 2, and this is 2. So altitude is 2. We already got half of it. We'll just kind of write this up in the corner to save time. So we know that because this and this is congruent angles, guess what we can do, guys? We can drop another altitude. And we have another one of these triangles, right? And because this is an isosceles trapezoid, we know that AD and BC are the same, and we are off to the races. Right. So, I have my AD is equal to 2, but that doesn't really matter. What we care about is what DF, I'll call it, is equal to. And that's equal to 2, right? Right, as well, guys, right? So, we know FE equals 10 minus 2 minus 2, right? Which is 6. So, 6 equals FE, but we know that if 6 equals FE, this is a rectangle, guys. Remember? Remember, I kind of made a little allusion to that earlier. This is gonna be a rectangle, so this is gonna be 6 as well, guys. Oh, this is all working out to be pretty good. So now we have 6 and 10. We know these bases. Take the median of those. Mean, sorry guys, mean. Take the mean of those. 8, is it not? And 8 times 2 is 16, and there we go. Gotta get some celebration music in here, man. That was a pretty, again, it's an intimidating problem, and not a lot of information is given, but you just gotta figure out a couple lengths, drop a few altitudes, just get started on these problems, guys. Just get started. Yeah. So, hopefully you're reading this problem now. If AB to AD is 3 to 1, and ABC is equilateral, and ACED is a trapezoid, what is the ratio of area ACED to area DBE? I'll show you guys 2 ways of doing this. The first way is to do it kind of mathematically, right? So, we know that if AB to AD is 3 to 1, then AB to DB is 3 to 2, right? Because how do you know 3 minus 1 equals this? So we have DB equals 2/3 of this whole segment, right? But we also know that DE is going to equal 2/3 of AC, is it not? Because we know that these are similar triangles, right? Because we know they share this angle, right? We only need 2 angles, though, sorry guys, to be similar triangles. We have 3 angles. Well, we know all the angles here, right? Because DE and AC are parallel. That is given. So, we know that all of these angles, and so angle D and E and A and C, so all of these angles are the same. They're all actually 60 degrees, in fact, because it's equilateral. So how does this help us? Well, in this case, we know that in 2 dimensions, this is going to be 2/3 of the whole thing. So we're going to take 2/3 squared, right? Phones are going crazy in this house. And then we're going to take that squared, so it's going to be 4/9, right? And that is the no. Hold on, guys. We didn't get the entire answer, did we? Because this is the ratio of the whole triangle ABC to the triangle DBE. DBE to ABC. But we want just ACED. Okay, we just want this trapezoid to this triangle. So we're going to take the entire area, which we're just going to call 9. 9x, and then subtract 4x, and we're going to get 5x. So, ACED to DBE. So ACED is going to be 5x. And DBE is going to be 4x. X's cancel, of course. Cancel with this x, of course. And we get 5 to 4, right? That was a bit of work. I mean, you know, took a couple of realizations, but what if you want to do that a different way? We had to use AA postulate, we had to, you know, some subtraction, a lot of complicated stuff, so I'm just going to undo this. Okay. I'm going to show you something that is going to be cool. Okay. Look at this. We have made these congruent similar triangles, and I can prove them, in fact, congruent by ASA, I believe. But, you know, if you want to, you know, that'd be a good thing, you know, prove these little guys congruent. You know, if you know, you have some spare time. But right now, I want to say that these four guys are congruent, right? Because I made them that way. And then these 5 guys are congruent to each of the ones in the 4 guys. So we have 4 in here. 1, 2, 3, 4. And then we have 5 here. So ACD to DBE is just going to be 5 to 4, guys. Isn't that so much easier? You just have to just spread it out into some stuff and divide the figure. Isn't that so wonderful? And it turns out that, you know, this top row is 1, then 3, then 5, and if you were to keep going, it would be the consecutive odd integers. So 7, 9, 11. But, you know, that's just, you know, in case you're using this method. So this is a great thing about how trapezoids and triangles are related, because really, a trapezoid is just a big triangle and cut off this little triangle. And you're left with this little thing right here, right? That's a trapezoid. And that is the video. So, please, guys, leave an amazing little like if you enjoyed this video, which I really hope you did. And then make sure to sub to PewDiePie, of course, because why not? And then sub to me and turn on the bell. Guys, enjoy your day. Enjoy trapezoids. You know, trapezoids, a lot of people don't understand them, and that's really the only problem that there is, you know. And I hope that you've picked up a lot of useful information about trapezoids that's going to help you in your geometry classes. Hope you got some insights. And of course, what are your ideas? Tell me. Either email me at my address, which will be in the description below, or comment. So have a great rest of your day.